So welcome students. So students, today we are going to learn some of the math about the math module and some of the methods, the functions of the math module. So this is a special module that we need to import before using any of the functions of this particular module. Okay, and how we are going to import that? We are going to simply use the statement that is import space math. So this will basically import that particular math module into your program, and then we can start using the functions of this particular math module. Okay, so some of the math modules I will just quickly go through and then we will just implement them. So some of the functions that we are going to look at is the math.ceil. So this particular function will return the smallest integer that is greater than or equal to the x value. So basically it handles the floating values. Floating values means with the decimal points, the number with the decimal points. So this is going to return the smallest integer greater than or equal to x. Okay, let me just quickly show you how to implement this. Okay, so if I say that is import math, so this is going to import the math module into my program. Okay, now that's the first step. And then if I say print and I say math dot and then C. Okay, that's the way to do it, children. Math dot and C. If I say 2.9 and if I run this particular code, what it is going to do me, let me just math module. Okay, so what it is going to give me is 3. Why? Because as I said that it is going to return the smallest integer greater than or equal to x. So it is going to return the number which is greater than 2.9, and the smallest integer that is that can be to the number that is next to the number, that is 2.9, and so it has given me 3. Okay, so the integer that is next to 2.9 is what we are going to give, is what we are going to get. So even if I say 2.2, and even then it is going to give me the value that is 3. Okay, so this is how this particular function works. Basically this is not called as a function, children, this is a method. Why? Because this is a function. Basically it's a function, but it is associated with a module that is math, so we call this as a method. Okay, so let's move forward now. And the next was the square root, and it simply gives the square root of the x. So let us just implement that. And if I say sqrt, okay, that's the exact word you're supposed to use. And all are in small case letters. Okay, so if I run this, so it is going to give me 9, because the square root of 81 will be 9. So you can find the square root of any number with this particular method, that is math.sqrt, that is a square root. Let's move forward. And the next that we have is the fabs. So fabs basically gives a absolute value of x. So absolute value of x means even if x is negative, it is going to give us the positive number. So if I do something like this, like fabs, and I say -2, it is going to give me 2, that's the positive. And the numbers that is been written by these methods will be in a floating number, so it is 2.0. And if I give 5, 5 is anyway going to be as 5.0, that is a floating number. And even if I say -5, so I'm going to get the positive 5. So this gives the absolute value, which is the positive number. Always it is going to return a positive number. So this is how this particular method, that is fabs, works. It gives the absolute value. Next what we have is the floor. So what is this particular method going to do? this particular method is going to return the integer which is less than x, okay, as opposite to the ceil was like greater than, this is going to be less than. So if I do something like this, that is floor, and if I provide some floating number, now if I say 5.9, okay, and now if I run this, it is going to give me 5 and not 6. If this would have been ceil, this would have given me, okay, if I make this dot and a ceil, and if I run this, it will give me 6. But if I make this as floor, this is going to give me the smallest value, so 5.9, it is going to give me 5. And please understand, we are not doing any kind of rounding of the numbers, okay, this is not like rounding of a number. But yes, floor, you can use this if there is some 5 point any decimal point number and you just want the integer part, you can use this particular function. Okay, so this is how it works. And then what we have next is the power function, the power method. So it takes two values, basically the base value and the power 2 value. So if I say something like this, if that is 4 comma 2, so 4 comma 2 is going to be 4 raised to 2. So if I run this, and we have an error because I did not change the name of the method, that is POW. And now if I run this, you can see it's 16. So 4 raised to 2, that is 4 into 4, that is 16. Okay, so this is 4 raised to power to 2. Okay, so this is how you can do it, children. If I simply make this as 2 comma 2, so this is like 2 raised to 2, and that is going to be 4. Okay, so that is the POW method, that is a power method. Then what we have is, children, we can calculate the sine values of x, the cos values and the tan values of the x. Okay, but before I go over there, um, one more thing I'm going to show you is what is the exponent of x. So this is basically e raised to x. So that is, if I really use this, so this is going to be exp, and the value that I'm going to provide is 2. So this is going to be e raised to 2, and e basically, this mathematical constant that we have. Okay, so this is going to be e raised to 2, and that's the value that we are going to have. Okay, so this is how it works, children. And then we have the sine, cos and tan methods. So how you're going to work with this is basically, if I say sin or sine of x, but I cannot simply straight away use like sine of 30. Basically this particular function we need to uh, you know we basically, when we work with sine, cos and the tan, we basically refer to the degrees, but we cannot provide the degree straight away like sine of 30 or something of that sort. Okay, we cannot do this way. What we need to do is, for that we have a method, that is radians and 30. So what this particular method is going to do is, it is going to convert this degree into the radians. Okay, so first we need to convert the degree into radians, and then if I just remove this and take this, so into a tenth. Why I can do this is because these particular methods, they basically return that value. So if I say math.radian, so it returns that value, and now I'm capturing that, I'm collecting that value into the variable, that is temp. And then what I can do is I can say print, and now I can say math dot then sine of temp, and now it is going to give me the the sine value. Okay, similarly I can use this as cos as well. Okay, and similarly I can use this as tan as well. Okay, so this is how you have to work with these particular functions. So you have to convert that degree into radians, and then you can pass that value. You can do it in straight away. What you can do it, another way of doing this is, I will not use any temp variable, but I can inside that again I'm going to use the math dot and the radians. So this way also you can do it. So but if you really find this confusing, then you can do the way that I showed before, and this is going to give me the same value. Okay, so that is a tan value you can see out here. Okay, so what I did is math.tan, and inside that I again I use the same method, that is math.radian. So the innermost method gets executed first, will be evaluated first. So this is going to math.radian going to return the the radiant value of 30 degree, and then that value is going to get passed to tan, and then we are going to have this output. Okay, so this innermost, okay, the innermost method is going to get evaluated first, and then the value that it is going to return, tan is going to convert that method, that is the tan value. Okay, so this is another way you can do it, children, if you do not want to use the temporary variable. And then we have some of the programs we can take, children, like this. Okay, how you're going to work with this, like if you really want to calculate this particular formula, that is square root of a square plus b square plus c square. So how you're going to do that? Okay, let me just delete this. I'll keep it math, that is import math. And then what I can do is I can use a variable temp. I will collect everything into temp, or straight away I can do everything into a print function as well. So I'm going to say math, name of the module, and then I need a square root. Why do I require a square root? Is because this is a complete square root. And then inside that what I can do is, okay, since this is a square, b square and c square, so this is a into a plus b into b plus c into c, right? I can do this. Okay, so how I'm going to write this, like a into a. So when I say a into a, so that is a, and then the asterisk sign, a into a, then plus b into b, and then c into c. Simply I can do this and collect that, and now we do not have the values of a and b. So I'm going to say a is equal to 2, b is equal to also 2, and c I'm going to give it as 4. And now then I can print the value, that is 10. Now if I run this, and we're going to have the output. Okay, so this is completely working fine. Another way of doing this is like this is, you know, if you check the formula, that is a raised to 2, so I can use that power method as well, but this will maybe a bit confusing. So I can say math dot pow, and then I will say that is a comma raised to 2, right? And then again that particular operation plus math dot pow and b comma 2, and plus math dot pow, and that is c comma 2, so that will be c raised to 2. Even this is going to work, children, and you can see the output, it is exactly the same, right? You can see the output, it is exactly the same. So you can use this also. So I have used the methods under some other method, so this is going to get evaluated first, then second, then third, and ultimately the addition of this, the square root is going to get calculated. Okay, this is how it works. And in if I do not want to use this temp variable, I can simply copy the entire statement. Okay, I'll cut this and paste it inside this print function. So that is now another. Okay, so I put under the print function we have the math dot square root, and inside this function we have these functions or methods. Okay, so this is also going to work the same way. Okay, there is a error with the brackets basically. So this is the opening bracket, closing bracket, opening, closing, opening and closing, and I do not have a closing bracket for this, I guess, if I'm not wrong. Let me just run this, and you can see now it has worked. So this is the same answer, children, what we had before. Okay, you can see out here, over here, and at the last what we produced is this. So that is how you can work with these children. And then one more program that we can take is this one, that is 2 minus ye, and that is raised to 2y. Okay, so that is y into e, and that e is raised to, so basically, okay, that's entire product will get raised to 2y, y plus 4y. So how we are going to do this is, okay, let me just do this also. Okay, I'll keep this as it is, and then let me just come to the next line, and I will simply say, I'll take a temp variable, and then what is the question, that is 2 minus, so I will say 2 minus, and then what we have is 2 minus, and that is y into e. Okay, e, that is e raised to 2y basically. So what I'm going to do over here is I'm going to say y into, and then the math dot the exponent function, and I'm going to say 2 into y. Why 2 into y? Because that's the question, 2y, so 2 into y. So e, where there is e, I have used ye, so y into e, and at the place of e we need to have y into math dot the exponent method, and in that is raised to 2 into y, that is raised to 2 into y, right, and plus 4y. So plus, and then I have to give 4 into y, and then I can simply print the 10. Okay, so let me just run this. Okay, y is not defined, I will take some other value. Okay, I'll take the value. Okay, children, so this has worked successfully. So this is how you can work with the mathematical equations, and do not worry, we are not going to really work a lot with these equations. So if you're really finding this a bit difficult, it's okay, we're not going to really work a lot with this particular methods, or this particular uh, module. But yes, this is a part of the syllabus, so you should know how to use this module. Maybe in the future we can use this particular module, or if you really go for some scientific calculations, in that case you have to use this particular module. So this is how you can work with this particular module, children. So today we have covered uh, a very important module, that is the math module. Okay, and these are the methods, and these are not the only methods that we have, but these are the frequently used methods of the module, that is math. So there are other methods as well. Okay, but these are the most frequently used methods. So that's it, children, for today. We will meet tomorrow. Bye for now.